So this is the battery that we're going to model an adapter for within Fusion 360 so that I can power a portable soldering iron using this 18-volt lithium-ion battery. And we can start by making a new sketch. And we shall just put a square in. And we don't have any dimensions for it yet. So what we need to do is to measure up our battery. So I have a set of digital measuring sticks. And the good thing about these is that they're completely plastic and really, really cheap. But actually being plastic is very helpful because whenever you're measuring things such as batteries, metal ones tend to get in the way and cause difficulties to occur. Now overall, this battery is 120 or thereabouts, 121 millimeters by approximately 80.5. And as you can see, as I trace this up and down, it's not flat on either of the sides, and also the top is not flat either. So we've got a little bit of a challenge on our hands to be able to try and accurately measure this up to make an adapter for this. Now I don't need the adapter to overhang by a large quantity on the sides or at the ends. In fact, at the ends I don't need it to overlap at all. It's actually going to be shorter than the battery because we don't need it to be longer. In fact, we only need it to be approximately that size, about 90. So let's put that in that dimension into our sketch. The other dimension is going to be probably about the same. It's going to be square. We should put in 90 on both. So this is a basis. We can extrude this, knowing that we can come back later on and change things should we wish to. And we'll just make it an arbitrary length or height of 25 millimeters. So the plan is to model something that basically fits just up to here, leaving this button free. So we can take our measuring sticks and just measure up this bottom part of this sliding shoe. And we're getting about 40 millimeters there. We can transfer this over to our design. Now before we do that, to make things easier, because when you print something out that you want a sliding fit, an easy sliding fit, you need tolerance. And you may need this in a number of areas. And when prototyping, you often need to change that tolerance. So to make things easy for ourselves, we go up to the Modify panel and Parameters. In User Parameters, you can see here that I've set up this. I've called it CC, just because it's an easy command to remember. And it stands for clearance. So here we want to create a rectangle, and to make things easier for yourselves we make a center rectangle. Whenever you scroll along a line, this little triangle symbol will appear when you're on the dead center. And then we can pull out and we can make it whatever we want. But what we want to dimension this. So what we measured was 40 millimeters, and then I'm going to put plus the clearance because we're going to be taking away or making clearance now, and then just press enter. And now whenever we perhaps need to alter that clearance, whenever we do our prototype, we can just alter it within the parameters instead of going into each individual dimension to adjust. Now the one thing we need to know is how deep this cutout needs to be. So let's go again back into with our measuring sticks. So we have the overall depth, or the depth down from this surface here. We've got 9.6. Check that elsewhere. On the other side we've got 10. So good job we checked. So we've got 10. So our dimension on this side, we are going to have, we're actually going to do 20 because we started our, we centered it on the top edge. And again, we're going to add the tolerance because this is a sliding fit. So that's got us the cutout for that. But this has little wings that stick out further. You may or may not be able to see that there. Now these wings overall have a 47, we shall say, 47 millimeters. So that's 3 millimeters bigger, 3.5 millimeters sitting out from here. Let's get our line tool, and let's just draw a line. Dimension that. 3.5 plus the clearance. So how far up does this need to be? This line here from our base. Well, we measured that the whole thing is 10 millimeters deep, and we can now measure the thickness of this lip is 3 millimeters. So that means that this little line needs to be 7 millimeters minus the clearance from the bottom. We know that it's 3 millimeters tall, but we also want to add double the clearance. So we add CC times 2. This line comes back. Zoom in here to there. We want to mirror this onto the other side, so it's very simple to do a mirror. You just get a line on the center line, select that line, press X to turn it into a construction line. Use our mirror function. We select these 3 lines. We select the mirror axis, click OK, and there it is. Now you may have noticed that all of these objects, these wings, are finishing above the top line of this, because this is too high up. So what we need to do is we need to select and remove the constraint that was tying it to the top. Instead, you can now drop this down, say like that. This gives us approximately 4.5 millimeters above this, which should give us enough room, because that tang, that green tang, sits up by about just under 4 millimeters. So actually we could do with that being a bit better, so go back, re-edit that, and we'll just bring that down. We can always come back and adjust things later on. So let's just save where we've got up to, and then we can extrude. So we select the 3 sections, and we're going to extrude backwards. Not going all the way through. We shall go to 70 millimeters just for the moment. So now let's just check these 2 outer ears, the dimension on them, and then compare that with our actual measurement on our battery. 47. Well, a millimeter extra, even if the printer prints off by a bit, we should be still alright with that. But we can always come back and alter that if needed. And we may, to make things easier to print, we may actually make that a bit wider. The easy way to do that is to come back on our timeline at the bottom, double click on it, and we can edit our sketch here. So we did have a depth of 3.5 millimeters. It doesn't matter if this is bigger or wider than it needs to be. So what I'm actually going to do is make this 5 millimeters. As you can see, it's all automatically adjusted at the other side as well. I've done this for a reason, because we're going to be able to chamfer these parts, in fact, or radius them. That will make them easier to print, but also a bit more attractive as well. Finish sketch, and there we go. The results are as seen. So next is modelling these 3 prongs sitting up, and this tang here, and also this angle here. So we'll start off actually doing that angle first, because that affects a lot of the dimensions where the other bits go. So what we need to do is we need to measure that angle. It's been a while since I've had to use one of these. There we go. So it looks like we're just about 60 degrees. We need to make a 60-degree angle on this area here. Very simply, take our line tool, make it whatever length we want. We want to make this, well, actually 120 degrees, because 60 degrees is going the other direction. Complete that. So now we want to extrude it. But before we do that, let's just measure what the overall width is, which is 90. And our actual battery is 80. So if we leave walls of 4 millimeters either side, would be adequate. So we can do the extrude command. The start is going to be an offset. It's 3. And then we want similar. I should have done -4. The other offset at 4 as well. As you can see, that's going to cut it out very nicely. That gives us our 60-degree cutout. And the good thing about leaving these walls a little bit long at either side is if we're off on our calculation of 60 degrees, most likely it will not be noticed or noticeable. So now let's turn to modelling up a slot for this green wedge, locking wedge to fit into on our design. If I turn it around that way, that's the way, the orientation of it going in. Let's create a sketch on that floor. So we want to measure up how big this needs to be. So it's approximately 29.8, call it 30 wide, and about 9 millimeters deep. Let's create a box. We'll do a center rectangle again. Oh, there we go. So width was basically 30 and the depth was 9. But don't forget we want to add clearance. So go plus CC and then plus CC. Now how far back does this need to be? Just rearrange the view there. How far back do we need to make this? Measurements, it's about maximum of 4 millimeters. We don't want it that far. We're going to put this 3 millimeters back. Maximum of 3 millimeters. In fact, we could probably go less than that. It's just that at 2.5. Having it a bit closer just means that it will drop in that bit easier. So now we can extrude that, go down, and we can find out the depth needed. 3.7, so we should say -4. Let's just make sure that we're not coming through the bottom. No, we're not. Now I could have added the extra clearance on that from the functions or from the parameters, but we were already making it deep enough. So now we move on to modelling the little 3 locating lugs. These 3 lugs need to be modelled into this back wall, and we also need to know how distance that back wall needs to be from basically here, the back of this green latch, to the front. So let's measure that. And we get 50 millimeters. Let's see what we have currently got on this. 55.9. So basically we need to bring this 5 millimeters closer. The easiest way to do this is to adjust the extrusion that we did for this. On our timeline, it's this one. It's handy, you can just hover over and it will show you which. So instead of -70, we just need -65. Now when we measure from there to there, we're now at 50.9. In fact, I'm actually going to give it an extra millimeter. A bit of clearance never hurts. So now we need to measure up the exact location of the little slots that are going to be needed in this. Now, in order to do this, first of all, I'm going to create a sketch based on that back wall. And I'm just going to put in some lines. That are going to make up the 3 pegs. We can get our dimensioning tool out. I'll show you a little trick that makes things just a little bit easier. When trying to measure these, it can be a bit difficult because we're measuring off effectively what's a wall that is hidden. It's underneath this piece there. So what I'm going to use is something to offset. And I'm going to measure this. And then zero out my... This allows me to come in and measure from that side, get that dimension of 5.8. 5.8. This is the dimension from this wall, not to there. That's the wrong one. Let's try that again. We're doing this one to there. Now keep in mind we've already got clearance added in, but we need to add here. I have made a mistake. I have been working on the wrong side, so let me just transfer. So 16.1 cc times 2 cc times 2 and then delete that one. Because we're working it upside down, myself mixed up there. So there we measure up for the third one, 36.4. There to there. 0.4 plus tolerance times 2. Right. Now we just measure up these. So let's zero out our measuring sticks. We've got 2.3 millimeters for this one, which is this one, believe it or not. So we've got 2.3 plus our tolerance. And we measure our middle one, which is 2.7. Bring that over here. Now I dimension it. 2.7 plus cc. Then our final one to measure up, 2.2. The thing is, what I've only actually done is put one amount of clearance into this, but actually we're going to need 2 of them, so 2 times now the height of these, actually 11 millimeters is going to be just fine for these. They only need to be 10 millimeters, but that includes a bit of clearance. And we can close off. Then we can extrude these. So I'll do E for extrude, select all 3 of them, and how deep do we need to go? Measure these. 10 millimeters. But these can go deeper. They don't. It doesn't need to be that short. We can go deeper than 10. And it doesn't matter that we're going deeper for these two shorter ones. Got plenty of meat at the end there, so that's not a problem. Cut those away. So we're actually at a point where it'd be very feasible to make a prototype from this. And then what I can do is export this as an STL and fire it up on the 3D printer, and then we can have a test fit with the actual battery and see if we're massively off in any of the directions or dimensions, see how we get on. So I've loaded the model into Cura, and just a little hint or tip: if you're making prototypes, you don't want to waste a lot of material. This one we don't need to print from the very, very bottom. We could lower it down just so it's got enough there, and that will be just fine. Just slice that. There we have it. So that's all for today. Thank you for watching, and stay tuned for more.